Our studio prop for this video is a model 20x2 machine that we made in November 2007. It's been in almost daily use since then. I'll use this machine to demonstrate the toughness of our systems. This early model, evolved out of about 20 years of prior experience making vacuum systems for a whole range of applications. But what we noticed in that prior experience, that what we had to do was really pay attention to joint details. These were the critical factor for achieving a leak-tight system. So one detail that we had to really work on was the connection between a valve and a manifold block. There is a tendency for valves to be rotated with repeated use. We had to make sure that joint could never loosen. Another one that seems kind of trivial, but is important, were vacuum gauges. What we found is that there was a tendency for people to rotate vacuum gauges if they were fixed in position, and almost inevitably they would create a leak. So of course our solution was to put an O-ring sealed joint in the vacuum gauge so that people can rotate the vacuum gauge, but it doesn't cause a leak. Another significant detail that we had to work on were joints that you had to connect and disconnect from time to time. And so this is one here. And so it was just important that every time a joint like this was reconnected, the vacuum integrity was immediately restored. So what we'll do now is just move in and take a close-up look at some of these details. So the detail we're going to focus on now is this joint between this block, elbow block, and the resin trap of the 20x2 machine. It's important that this joint retain its vacuum integrity for the life of the machine, and there's always a chance that people will push and pull on this hose, which they are doing every time they reconnect the machine. So the way we solve the problem of this rotating is we lock it in place. So our manifold block, or our elbow block, has actually got a step formed in it, and that step locates on the side of the resin trap, and when it's correctly in position we bolt it from the inside. So a bolt comes through from the inside, a hollow bolt, and we lock that in position. Once it's done up from the inside, it can never come undone. We're now going to talk about the joint that we make between a valve and a manifold block. A very important joint, because people are handling the valve all the time, and there's a tendency for them to want to rotate the valve, and then that ultimately weakens that joint and creates a leak. And the difficulty is with conventional threaded joints that when you position the valve where you want it, which is in our case with the handle parallel to the face of the manifold, it's inevitable that the thread isn't quite tight. So you either over tighten the joint and you try and take it round almost a full turn to get it tight, in which case you weaken the thread, or you leave the joint slightly loose and just hope that the thread sealant will hold it tight, and inevitably that doesn't work. So on a Vacmobile we do things slightly differently. We pre-fit a long nipple, I'll get this out of the way, we pre-fit a long nipple into the valve, and then we run a backing nut or a locking nut onto that nipple, back it up out of harm's way. These joints have normally got thread sealant in them, so this is just a dry run. Now you see, when the thread's tight, the valve handle's way out of the position we want, and we have to come back almost a half a turn to get it to line up where we would like it to be. We can do that. We do this all in a jig so that the valve handle's held exactly where we want it. Then we bring this locking nut down, and by means of these very large spanners we can then lock up that joint, and it will stay permanently in that position for as long as the life of the machine. We'll now demonstrate that by going to the machine itself. This has been sitting at vacuum since yesterday. I'm now going to apply as much force as I can to this valve to see whether I can loosen this joint down here. So if we're watching, just watch the gauge. If the gauge leaks, then we have a problem with the joint. If the gauge doesn't move, then the joint is fine. So there you are. I've put a lot of force on that valve handle. Gauge hasn't moved at all. That joint's 5.5 years old. That valve has been used almost every day. So not many vacuum systems you can apply that much abuse to. We're now going to look at a joint that may need to be disconnected and reconnected from time to time. And it's this one here under the manifold. To disconnect it, I just loosen the gland nut a little bit, maybe quarter of a turn, pull out the male part of the hose. When I'm ready to reconnect it, I just push it in and I just tighten the gland nut up again, just finger tight, that's all it needs. If I now switch the pump on, you'll see that the pump comes quickly to vacuum, and that joint will hold vacuum just like it did before. So while Vacmobiles may be small, they're very tough, as we demonstrated here, and very easy to use.